Hi. Okay. So my name is Martin Ponce, student ID 1037138 and this is my presentation for option 4 for CSI 3344 assignment 2, which is the mini RMI project. So assignment's due Monday, 20th of May 2019. You can get all the source code and the source for these slides at this GitHub link. And if you've got any questions, contact me on my email. All right, let's keep going. So just a quick overview of what we're going to talk about. We're going to give an introduction on RMI, what it is, how we do it in Java. We're going to look at an overview of the application itself, its design, how to set it up, how to use it, and some conclusions I've come up with and the references I used to develop and come up with this slide. So as a quick intro, what is RMI? It's a method of communication between clients and servers in a distributed system. It's closely related to RPC, which I'm not going to explain in this presentation, but Tannenbaum and Steen, they describe it as RPC, which is fully integrated into a programming language. And according to Oracle, to the programmer, remote communication looks similar to regular Java method invocation. So I'm going to paraphrase all of that. The way I understand it is all the communication implementation details of distributed systems. When you use RMI, that's all abstracted away from you, and all you really need to worry about is calling a function from an object, and which is quite cool. Even though those objects might be distributed, it's quite handy. So how do you do it in RMI? So I used Oracle's documentation. You can follow the link or my reference here. And it shows you how to implement RMI in Java with like this Hello World program. So I guess the first thing is you need to extend or define a remote interface or an interface, and it must extend remote. And functions that you declare in the interface must throw remote exceptions. So just quickly, let's look at my source code. Interfaces. Give me a second. All right, so ISS. Whoop. Don't want that. I don't know if I can increase the. There we go. So let me bring this down. So you can see I declared an interface called ISS. It extends remote, and all the functions that I've declared, they all throw remote exceptions. So back to the presentation. And remote objects. So they must implement the remote interface. They must also extend unicast remote object. This abstract class is responsible for exporting the remote object, and it obtains the stubs to communicate with the remote object. I believe before Java 8, you had to generate static stubs with RMIC, or at least it was optional. It's now been deprecated in Java 8, and stubs are now generated dynamically, and all you really need to do is extend unicast remote object, which is cool. You don't need to deal with any static class generation, which is awesome. Another part, oh, actually, before we go on, so remote objects, I'll give you an example of that. Let's look at what implements ISS. I believe it's in my server. We'll talk about this more in the design as well. So honors engine, let's put ISS over to the side. There we go. Same. Okay, so interface on our right, implementation, remote object on our left. It's called honors engine. It extends remote unicast remote object, and it implements the interface ISS. So the first implementation, let's see, here's the assess function. And here we have the implementation detail. Similarly, we have the implementation for the other functions as well. Easy to follow. That's cool. All right, next, the next component of a Java RMI is the RMI registry. It's bundled with the JDK, and you can spin it up within your own class, but it also comes with its own binary, and you can execute it as a separate service in its own thread. So you need RMI registry. Servers register their remote objects to RMI registry, and then clients look up references of those remote objects from RMI registry. And then there's this class called naming, which is responsible for the registration and lookup. So the servers use it to register their remote objects to RMI registry. And then the clients use naming to look up references from that RMI registry service. And the format is //host :port/name. And I'll show you later. So I'll just use localhost :port. I think the default's 1099 / and then whatever name I've decided to use. Cool. So we're going to get down to the application now. Now, the purpose of this application or this distributed system is to assess a student's unit marks and determine whether or not they're eligible for honors study, and it responds with a message to the user in the front end. So the architecture, as I guess outlined in the assignment brief, it must be distributed and it must be 3-tier. So I guess at the very top we have client, which acts as a client to the server, and it's a front end via a command line user interface. We then have, underneath the client, we have a server which applies business rules to user input from the client. It assesses students' eligibility for honors study and then responds to the client with that eligibility message. It also acts as a client to persist, or the persist layer. So in order to interact with the database, it sends or calls a remote object in the persist layer to recall and store data from some remote database. In my case, it's MySQL hosted on some free service, and the communication between all these tiers and services is handled via RMI. Here's some requirements. We're using JDK 1.8 and newer. I'm using some stream stuff that's only available from Java 8 onwards. I did use OpenJDK 12, however, and you also need Maven 3.6 if you're going to build this. It's a Maven project, but my repository includes Maven wrapper, so you don't even need to install it. Next bit, just quickly, so the tools that I used, so version control, using GitHub, or Git and GitHub. For my continuous integration pipeline, I'm using Travis CI. To determine code coverage, I'm using coveralls, and then this static analysis, so it picks up code smells and stuff. I'm using Codacy. So just on that, so 3 of these things, Travis CI, coveralls, and Codacy. You might have noticed on my front page, this is really just from my README. On GitHub, I've got some badges. So yeah, Travis CI, my builds are passing. I've got 83% coverage, and my code quality is A, which is awesome. Cool. So where am I up to? Tools. Right. So next, moving on. So the design, I've got an interfaces package, which contains all the remote interfaces. Then I have 3 services: Honors Persist, Honors Server, Honors Client, which have their own implementations of some remote interfaces, and then I have a couple of other modules: Honors Core, Honors Persist, Hibernate, which I'll talk about quickly. So Honors Interfaces, it contains all the interfaces. iPersist, which saves, recalls student unit marks from a database or from some persistence service. ISS, which is responsible for assessing marks for honors study. And then IAuth, which authenticates users. And this package, Honors Interface, is made available to the class path of RMI registry. So when it boots up, it has references to those interfaces, not the implementations, just the interfaces. And then we have another service called Honors Persist. This is, I guess, at the bottom. It acts as a server. It hosts the remote object implementation of iPersist. I think it's just called Persist. It defers the actual implementation to the package Honors Persist Hibernate. And the reason why I chose to do that is, what if I wanted to, or we needed to change, I don't know, to some other other persistent service like MongoDB or whatever. All I really need to change is a reference to some other package, and it just plugs in automatically. I don't need to change anything else. And well, in this certain situation, we're using Hibernate ORM, which interacts with a remote MySQL server. Cool. And we have the Honors Server service, which, as I mentioned earlier, it acts as a client and a server. It's a client of Honors Persist, which saves data via, or interacts with the database via remote objects. It's a server to Honors Client, as it hosts the ISS remote object implementation, which applies business rules to student unit marks and replies with some assessment result. It also hosts the IAuth remote object, which performs user authentication. It's super basic. Only a single user at the moment can use or can authenticate. It's hard-coded. There's nothing fancy, and there's no way to register new users. It wasn't in a brief, so you just authenticate with username, admin, password, admin. Very basic. Next, we have the Honors Client. It acts as a client of Honors Server. It functions as a front end for the entire distributed system. It's implemented as a command line interface, and I'll talk about what I wanted to do versus what I actually end up achieving, some limitations of RMI. But yeah, I just went ahead with command line interface. It calls IAuth, the remote object implementation, to authenticate a user. It calls ISS, or that remote object implementation, to assess a student's marks. And it also provides a way to create load and delete unit marks, which calls an object in the Honors Server service, which then in turn calls some object, or the iPersist object, in Honors Persist. And then we have like these other smaller packages. Honors Core, it's common abstractions shared between all three services. For example, like models that are the same between some client, some server. Right, so the usage. I have created 2 scripts to essentially build and start all of the services up in, I guess, the required order. There's a PowerShell version, start Honors PS1 for Windows users, and there's a bash shell for Mac OS Linux users. So essentially, yeah, as I said, it wraps the build and execution. All it really does, though, is it just executes everything in the correct order that it needs to. So the first part is it builds using Maven all of the modules. It starts the RMI registry, waits for that to fully initialize, then starts the Honors Persist service. The reason why we wait for RMI registry to completely initialize is once these services, the other services start up, RMI registry needs to be ready for these services to register their remote objects, and then look up others if they need to. So it starts honest persist, waits a little bit because it needs its object, or the persist object, to be registered before honest server can start up, and then look up its a reference to the persist object, and then it starts honest client. Cool. Like I said, authentication. There's only one user you can authenticate with at the moment. Admin. There's no way to register any new users. I believe I made the assumption that was out of scope. So yeah, one user you can only log in with, which is fine. Right. So here's, I guess, operation examples. I've used ASCII Cinema to record some video. Each of these slides, the image is clickable. It will take you to the correct recording. But since we want to do a demo, we'll just do it live ourselves. So let's look at the qualified example. I'll show you some examples of, I guess, input validation as well, and how the app all hangs together. So I hope this is big enough. So let's start off with the script. So I'm using the bash script to start everything, all 3 services and RMI registry. Now it's building. So it won't be long. Cool. So it just started RMI registry, and now it's waiting 30 seconds for RMI registry to begin. As I mentioned earlier, RMI registry needs to be fully initialized before we do anything else. So I just gave it a 30-second sleep, just to be sure. Cool. Now it's starting honest persist. All this info message is, I think it's hibernate RM, being a bit chatty. So here we go. Persist has bound its object to that name, to RMI registry, and now it's waiting. If you can see, there's at least two tags that are for every log event. The log level, and I guess I should explain that all 3 services, or persist and server, are started as background in background threads. So in order to differentiate between what event is from the persist server or client, you'll notice that there'll be relevant tags. So it might look like a single application, but in reality they've started up as background processes, and I'm using these tags to, I guess, identify which service is doing what at the time. So after the persist started, you can see that Honors server started as a background process. It then registered Honors auth and Honors assess remote objects to RMI registry, and then the server started waiting. And the last, I guess, service we started is Honors client, in the foreground this time, because we want to interact with it, and it's given us a little welcome message, and it's asking us to log in now. So just a quick one, we're going to log in with an invalid user. Let's see how that behaves. Right, so we logged in with a wrong username and password. The server said login failed as an error, and then the client, I guess, returned the exception or exception message, and it's saying RMI remote exception login failed, and the client says try again. So let's try again with a valid login. Cool. The server said login successful. The client said, okay, I'm ready for some input now. So the next bit of input is a student ID. I'm going to use a student ID that has actually already exists in the database. It's the student and course. So let's try this and see what happens. All right, so the server says load student and course from the database. The persist layer said, all right, I'm going to load or retrieve 12 rows from the database, and it's all returned to the client. Existing course found, and here's all the unit details. And it's asking, the client asks, now we can keep or delete what we found in the database. If we keep, we run an assessment on the existing data. So we'll run an assessment in the server with whatever we found in the database. Otherwise, if we delete, it will just delete all the rows, and then we'll start again, and it will ask for user input. So let's do K to keep just to see what happens. Right, so we see instantly we were able to run an assessment on the existing data. So course not deleted, sending request to server for assessment. The server came back with this response. We have too many failures because I believe the business rule is more than 6, or 6 or more. Sorry, let's check that because I might have that wrong. 6 or more fails. So thank God I got that right. 6 or more fails. So you can see unit 1 to 6 were failures. Instantly, too many failures. Student denied. Right, so we can press any key to try again or Q to quit. I'm just going to hit enter. So let's try again. Let's do the same thing. 1, 2, 3. Right, so and also I should have mentioned, you can see there was a little bit of a wait when we look up the student and course from the database. That's because it's a blocking call, it's synchronous. I don't have any async await calls here. It's all blocking. You have to wait for the operation to finish. So now again we found the same details, but in this case we're going to delete. Again, it's blocking. We're waiting for the database or the persist layer to do its thing and return or bubble back up to the server and then the client. So we can't really do anything at the moment. But right now it's deleting 12 rows from the database. Cool. Now it's finished deleting, and the client's now asking us enter unit ID and mark for a minimum of 12 units and a maximum of 30 units, or E to end input or Q to quit. So I'm going to explain what E to end input means. So we have a minimum of 12 units. So let's say you've entered 12 or more, but less than 30 units. You have the opportunity to exit the input phase and get an assessment. So let's just start doing this. So we now have to enter unit ID and mark, and then gives us some other control options. So E to end or Q to quit. Let's just enter unit 01, and let's go for what is our first rule? Course average greater than 70, equal to or greater than 70, right? So let's just go 70. Now, it expects our input to be in this format, the unit ID, comma, mark, an integer, and it must be greater than 0, less than or equal to 100. Equal to or greater than 0, between 0 and 100 inclusive, is probably a better way to say it. So let's just do that. So it accepted that input. Let's try and end now, see what happens. If I try and end now, the client says, error, still need to input at least 11 more unit marks, and it must be in that format. Let's try unit 02, but entering a negative number. Right, mark must be between 0 and 100. What happens if we enter something greater than 100? 101. Cool, that's fine. So unit 02. And then what happens if we do ABC? Right, enter, error, mark must be an integer. And what if we just go crazy and ended up, I don't know, typing something like this by mistake? Are we validating? Yes, we are. So it knows we just need the two elements separated by a comma. So let's just put in a legitimate mark now. So 2, 70, unit 3, 70, unit 4, 70, unit 5, 70, unit 6, 70, unit 8, or 7, sorry, 70, unit 8, 70, oop, 70, unit 0, 9, 70, unit 10, can't type, 10, 70, unit 11, 70, unit 12, 70. Right, so we've got 12 units in. We can now end input, hopefully. Cool. User input is complete, and it gives us an option. We can S to save course details, C to continue, Q to quit. Explain what that means. So S, if we hit S now, we're going to save stuff to the database. If we hit C to continue, it'll skip saving to the database and just ask for an assessment from the server, or Q, we just outright in the program. So let's just save. Let's see what happens. So right, so we're saving unit marks, or saving marks for student 123, course 123. Server has sort of logged that as well, and just to show that we're asking the server, and then the server's gone and asked the persist layer to insert the 12 rows, and then the client has then sent a request to the server for assessment. The server's returned that their average is 70 because that's all we entered, and they qualify for honor study. So here's our output, and it's asking us, do you want to try again or Q to quit? So let's try again. Let's go for another rule. What's the next rule? Further assessment. So average is less than 70, but the average of the best marks is 80 or higher. All right, let's see what we can do with that. So let's use the same student again, and course. Right, now we're going to delete, or we're deleting, so now we're deleting the 12 rows, so we start again. My next example will skip this part. Well, let's use a new student in my next example to save time. But I just wanted to show that one more time. All right, so here we are. We're at that data input stage again. So unit 01, what was the rule? So we want average is less than 70, but the top 8 is 80 or higher. So let's just go, let's go 90 for that top 8. Unit 02, 90, unit 03, 94, 95, 90, unit 06, 90, unit 07, 90, unit 8, 90. Right, so then let's just go make a pass. Unit 09, 50, unit 10, 50, oh shit, unit 10, 50, 11, let's go to 15, drag the average all the way down, 13, unit 14, unit 15, let's go 16, just to be sure. All right, E. Let's save it. Now we're inserting 16 rows to the database. Oh, damn. Damn. Okay. Maybe the average too high. Okay, that's cool. Let's try again. This time let's skip all the database stuff. can't maths. 1, 2, 3. 3, 2. 1, 1. Course 1, 1. Hopefully it doesn't find any rows. Sweet. All right. So return 0 rows. This student course does not exist in the database yet. Right. So unit 1, 80, 02, 82, 03, 4, 5, 06, 7, 8, 80. Now, 9, 10, 15, 11, 12, 13, 14, 15. Let's try it, all right? Let's skip entering the database. Cool, here we go. So, we sent an assessment. We didn't bother saving to the database. Went straight to the assessment. Our average for the entire course has been 66, but our top 8 is 80, so we might have a good chance, right? But we need further assessment according to this rule. Right, so next rule, course average is less than 70, but average top 8 is between 70 and 79. We may have a chance, but we need to get special permission from the coordinator. So let's try and get to that state. So student 111, we shouldn't find any rows for this because we skipped the save step. There we go. So unit 1, let's go with 75, bang in the middle, unit 02, 75, unit 03, 75, unit 04, unit 05, 75, 06, 5, 07, 08, 75, unit 9, 75. Oh, damn. Okay, unit 10 should be 50. Go to 16 then. 11, 50. Unit 12, 50. 13, 50. 14, 50. 15, 50. Unit 16, 50. One more. Why not? We're still in there. Actually, you know what? Let's go all the way to 32 to see how it behaves there, because that's, or 30, I think that's a maximum, right? I haven't showed how that operates yet. Unit 20, D, unit 1. A bit tedious, isn't it? But let's just go there. 23, D, 24, 15, 25, 50, unit 26, 50, 27, 50, unit 28, 50, 29, 50, unit 30, 50. Let's see what happens. Okay, user input complete. So we'll max out at 30, won't let you do any more. Again, it asks whether you want to save or continue. Let's just continue. Awesome. So you can see our average is 57.50 across the entire course. Our top 8 average is 75, so we may have a chance, but according to the rule, we need special permission. That's from the server. Client pretty much says the same thing, and let's try again. So what's the other rule we need to go with? Just flat out denied. Right. So that means if our course average is less than 70 and the top 8 is also less than 70, we don't qualify. So let's try and get to that state. So 1 course. Right. Shouldn't find anything. Excellent. 0 rows. So unit mark. So unit 01. Let's go 60 this time. Unit 02. Unit 03, 04, 5, unit Okay, that's top 8. Unit 9, 50. Unit 10, 50. Unit 11, 50. Unit 12, 50. Unit 13, 50. Unit 14. Let's go. Unit 15, 16, 17. That's just to be sure. All right, okay. That should be enough. Bring it down. So let's end our input. Let's just continue. We don't need to save this to the database. Then bam, our response from the server. We have an average of the entire course of 54.71. Our top 8 average is 60, which makes us not qualified for honors study. We should then do masters by coursework instead. So those are our business rules applied. I'm just trying to think now. I've showed you input validation. I've showed you the business rule where if we have more than 6 or more fails, then we're just flat out denied. And I've showed you all the business rules according to the brief. So back to the presentation. I've showed you qualified. I showed you needs further assessment. I showed you needs permission. I showed you not qualified, disqualified. Right, so down to the conclusion. So to conclude, this presentation demonstrated RMI in Java. Excuse me. RMI in Java via a 3-tiered distributed system. I did find a problem with RMI, maybe because there's just our browsers, there's an issue with our browsers, but let me go through it. So the problem I found was there's a direct conflict with the goal, one of the goals we spoke about in the first lecture, which is, I hope I am pronouncing this correctly, heterogeneity. The problem is that you're forced to use Java for both the server and the client. What I really wanted to do was create a web app front end for the server, or to act as the client for the server. But if I wanted to do that, I needed to develop this web app with a Java applet so that we could use RMI. And modern browsers just don't support that anymore because of security reasons. So if you were to ask me to do this assignment without any restrictions, I would have used REST API, which I think, to be honest, is a more modern solution to what we're trying to achieve here. And it's a shame that just if you look at RMI in Stack Overflow and trying to find some stuff via Google, everyone says no one does RMI anymore or RPC. Everyone's on REST API, which, I think they're right. So I just wish, I don't know, maybe this is a problem at all unis, but ECU's kind of behind the ball as far as keeping up with tech stack and what's out there, which is a bit of a shame. Nothing against GTN personally, but I just see this in all of our units at ECU, which is, I think, maybe a place we could improve. But I digress. I apologize for the rant, but yes, that's my conclusion. I would have used REST API. And here's my references for this assignment. Sorry it took so long. I appreciate you taking the time to watch this. Thank you. Yeah.